Well, hello and welcome to Math 1D Exam 1 practice problems. In question 1, you have functions and the question says find the domain of those functions. Domain of the functions. So in question 1, the function, the very first function that you have is f of x and y equals to. So the equation is x plus 2y minus 5. If you remember equation of a plane, this is just a plane. So it means that this plane expands in the space in all directions. So there is no restriction for values for x and y. You can say that, hey, the domain of the function is actually all points in xy plane or Cartesian product with r, which is represented by r squared. For question 2, you have the following function. You have f of x and y equals to square root of x minus y. Very well, remember that. When you have a square root function, the quantity inside the square root cannot be negative. It's either 0 or positive. So to find the domain of the function, you can say that, hey, the domain is equal to the set of all points x and y such that these x and y's are actually satisfying this relation that must be greater than equal to 0. X minus y must be greater than equal to 0. So what's the meaning of that? It means that the quantity inside x minus y must be greater than equal to 0. It means that you get all the values that satisfy the inequality y less than equals to x. This is your domain. All points that satisfy this inequality. Very well, let us take a look at question 3. In question 3, we have f of x and y equals to 2 divided by x plus y. Very well. So as you can see, you have a rational function. When you have a rational function, you have to be careful about the denominator. The denominator cannot be 0. So the domain of this function, domain, is equal to the set of all points x and y such that the denominator is never 0. Or y is never equals to x. If you graph it in xy plane, you have to exclude the line y equals to x. Very well. Your question 4 is actually inverse tangent. For inverse tangent, you just need to be careful about the denominator. So for question 4 says you have f of x and y, which is inverse tangent. Let me check the question. Y divided by x. So the domain of this function is equal to the set of points, all points, such that you just need to be careful about the denominator. Your denominator cannot be 0. Inverse tangent. Well, next function is actually another rational function. So for question 5, here you have f of x, y, and z. In this case, you have x divided by yz. X divided by yz. As you can see, this function has 3 free variables. Very well, to form the domain of the function, the domain is equal to the set of all points x, y, z such that the denominator is never 0. So by the condition that yz is never 0. Very well. In question 6, we have x times sine y plus z. Question 6. X times sine y plus z. Very well. Take a look at this function. This is a nice function. Why is that? Because you have x and sine is a nice function as well. So for sine function, you can actually plug in any value for y and z. Just note that this function is a function in four-dimensional space because it has three different free variables. So the domain of the function, domain, is equal to the set of points x, y, z such that all of these are free. X belongs to R, y belongs to R, and z, all of them belong to R. So the domain is R, Cartesian product R, Cartesian product R, or R to the third power.